This is video 2 for the control systems. So in this one, we're going to talk about how to actually program in Robot C. This is a text-based programming language. Commands to the robot are first written as a text, so it's something you'll type up. Then there's something called a compiler, which will then convert your text into machine language. So it converts all of your words into ones and zeros, something that the robot can understand. Then it'll send it to the robot so that the microcomputer on the robot can run your program. So here, this is a very, very simple start to code, and this is basically this is all you really have to know. So let's take a look at this first part here, where it says task main, and then these squiggly brackets here and here. This is called a control structure. All of your code will go within the squiggly brackets in the control structure. So looking at it then, you'll take a motor, you'll wire it into port 3. Now remember, the motors are 2-wire, so you have to use a motor controller 29 to convert the 2-wire into 3-wire. You can plug that into port 3, and then you can set the power from 0 to 127. And then to tell the computer how long to leave it on, we use the wait 1 capital M SEC, and then in parentheses we put how many milliseconds. So 3,000 milliseconds will be the same thing as 3 seconds. When you write code, you'll have individual statements, and these are simply instructions for the robot. You can think of them as commands. So when we take a look at our code and our control structure, the motor, and then in square brackets, port 3 equals 127 semicolon. That is a simple statement. It is a straightforward command. And that basically tells the robot to turn on the motor that is attached to port 3 at full power. The second simple statement, the wait 1 capital M SEC, that's basically to tell the robot to wait for 3,000 milliseconds before turning the motor off. Now the statements are run as quickly, or they're run in order and as quickly as the robot is able to reach them. So first off, the semicolons. These tell the robot that one statement has ended and the next statement needs to begin. Now Robot C tends to use more punctuation than English. For programming languages, punctuation, it separates important areas of code, and usually punctuation comes in pairs. So for things like sensors and motors, we use square brackets. So, and we usually use those to identify what port something's plugged into. For parentheses, we use that for time. So 3,000 milliseconds is a time, so we use the parentheses. Now, with that knowledge alone, you can probably handle everything just fine. So let's start introducing some new things then. This first new thing is called a variable. And what this is a place to store values. By values, I mean maybe like sensor readings. And we are storing these values for later use. maybe we want to use these values in a calculation. All right, so there's a certain steps that you have to follow if you want to use a variable. The first thing you need to do is to introduce your variable. We want to declare it. The second thing we want to do is we want to give the variable a value. So we want to assign it a value. And then third, we want to use the variable to access the stored information. So let's see how that looks in some code. So in this code, we're going to turn on two motors for 2,000 milliseconds. So first off, notice that we have our control structure. It's the task and its main. And our code is between these two squiggly brackets. So the first thing we want to do is we want to make our declaration. Now you'll see this little tiny thing right here, int. We use int, it's short for integer, so we use it for numerical values. And if you use it correctly, it'll turn the font blue. So that's our declaration. We're going to make an integer, and our variable will be speed. You can make the variable v if you wanted to, it doesn't matter. But once you type in int, it tells the compiler that whatever's after that will be your variable. And notice we have a semicolon after that. The next thing we need to do is the assignment. So we're going to take our variable, which is now speed, and we're going to assign it some value. So right now we're going to assign a value of 75. Finally, we're going to use that in our code. So here we have two motors. They're plugged into ports 2 and 3. And we want both of them to have the value speed. So basically, this is saying to turn motors and whatever motors are attached to ports 2 and 3, we're going to turn them on at a power rating of 75 for 2 seconds. And what's nice about this is if you wanted to make a change, you can change it right here instead of going through your code and trying to find it every single place and changing it individually. You only have to change, if you want to adjust your code, you only have to do it once instead of twice. The next thing we need to discuss are functions. This will be a group of statements that are run as a single unit when the function is called from another location. Now, the reason why we want to use functions is so that we can save time and space. It's so that we can separate behaviors into different functions, and so that tasks can be handled with a single intuitive function. These will be our void statements. So, taking a look at this, we have our control structure here, our main task. what we're going to do is we're going to create a function that exists outside of that main task. So we start with the word void. Now here we see that void, and we're going to give that function a name. So it's going to be called forward time, and we're going to declare a variable which is going to be an integer, which is t for time. So we have in our forward time function, we just have motor port 3, motor port 2, 127, wait 1 millisecond. This time we're going to use our variable. So we're just going to plug t in there. Then under the main task, we just call up the function. So we type in forward time, and then in parentheses, we can put how many milliseconds we want those motors to stay turned on, which is kind of handy. Now, while we're here, we see another line of code. B motor reflected port 2 equals 1. That statement just simply turns motor port 2 from positive 127 to negative 127. It just it reflects, so it just flips it backwards. So instead of turning clockwise, it'll turn counterclockwise. That's a useful line of code if you want to use. I honestly don't think you have to. I would just personally, I just leave that code out, and then in port 2 I just put a little negative sign. Take care of it up there. But if you want to use the B motor reflected function, that's fine as well. All right. The final thing I want to discuss in this video will be global variables. And these are variables that can be used inside of a function. It was declared, or I'm sorry, they can only be used inside of a function that it was declared. And the global variables are outside of the function. So that's how normal variables work. Global variables are outside. So let's take a look at some code here. So first off, we can see our control structure right here. We can see our function right here. And notice that even outside of that function, we have another item right here, another integer, which we're calling time value. So that is a global variable. And notice that I can use this variable time value inside my function and inside my control structure. So looking at this, we can write some sort of code that uses it in both places. There is a problem though. You have to be very, very, very careful when you use global variables. Notice that in this code, the global variable time value is worth both 6,000 and 2,000. That means the computer really won't have any idea what to do. Should it be 2,000 or should it be 6,000 milliseconds? So when you do use global variables, if you use them, be very, very, very careful. It is my opinion to avoid global variables entirely, just so that you don't have any errors popping up in your code. All right, that concludes this video for this section of the notes.